Hi everyone, welcome to our presentation about enabling infrastructure as code at LinkedIn. So today we are going to talk about how we went from our journey of an imperative programming model for infrastructure to adopting a declarative infrastructure model for LinkedIn. So a little bit about me. I am a senior software engineer at TFAS and I work in building the core Terraform features, and also I work closely with the other infrastructure teams at LinkedIn in getting the vision of IC and also the provider ecosystem getting adopted at LinkedIn. So Wensi will join us later, who will talk about the core Terraform features, the core features of the platform that we are building, and also about some of the impact and metrics that we had by using IC at LinkedIn. So let's get started. So this is how the agenda for today looks like. So first, I'm going to talk about why did we decide to go with infrastructure as code at LinkedIn, and also what are we doing to make this vision of IAC realized at LinkedIn. So we'll share a few things about TFAS, the platform Terraform as a service that we have built, and also how does it actually work. And the next we'll talk about the provider ecosystem, the Terraform provider ecosystem that we are trying to build at LinkedIn, and how does it enable us to in getting the IC adopted at LinkedIn. And finally, we'll see some of the metrics, the impact that we have from TFAS users at LinkedIn, and also how we are using TFAS, in what ways TFAS actually helping the LinkedIn infrastructure. So first, I want to talk about why did we actually choose to adopt infrastructure as LinkedIn, and why was it actually needed. So back in the time, so about 3 years back, when the LinkedIn infrastructure was using the legacy system that was built over the years, first of all, there were too many tools and CLIs that users had to use. Like if you want to configure, say, one piece of infrastructure, then you have to use one tool. And let's say if you want to configure, for example, Kafka queue or something, then you had to use another tool, CLI or a UI for it. So we wanted to unify it, all of these together. We wanted to have a unified model where you can declare your infrastructure as code, and it should ideally live in the same place where also your application code is living. So that was one of our primary motivation for driving the IC, for going behind the IC and TFAS adoption. The second one was, as I already mentioned, if we use a different, let's say, frameworks, different kinds of tools and CLIs or UIs, then we we are already in a phase where you are using the imperative programming model. So in that case, you have to like write the logic for everything that you want to do, where you want your system to take. You have to write an, in a way, hard code logic for all of that. While while using IC and using Terraform, you can do all that declaratively. So you just can declare the final state where you want your infrastructure application to reach in a simple Terraform file or a config file. And then we make sure as a platform that we bring your infrastructure to that state finally. And due to all this, we also realized that we had a low productivity and efficiency in our engineering teams. We were not pushing infrastructure, like releasing new versions of infrastructure and making iterations as fast as we wanted to do. So, and we realized the root cause of all this was still lied at the imperative programming model and the way we were handling our infrastructure. So we decided to overhaul all this and make a shift to IC and using Terraform. Now, as I already mentioned in brief, few use cases or a few advantages that IC or Terraform provides us. I'll just reiterate them briefly here. So first one is that it provides a great development velocity. So using Terraform, using infrastructure as code gives you an ability to deploy new resources or environments very quickly. So if you, let's say, have a template for one of the resource, then you can quickly go from 1 to 1,000 resource in a very like easy manner. Also, it helps you to automate your resources. It helps in reducing toil. You can also do a parallel provisioning of all your resources. You can just declare as many resources as you want in your IC file, or let's say a Terraform file, and we will make sure that all your resources are provisioned parallelly. So by doing this, there's also a consistency in a way that we write IC code or we write Terraform code as LinkedIn, because earlier there were a lot of teams, they were using their own Terraform implementation. They were trying to use Terraform, but there was not a consistent way to do it. And using IAC and Terraform, it provides you with a consistent way of doing this. So there's also an accountability because we treat IAC code as same as application code because infrastructure should be treated as code, and we can have auditability due to the state files that Terraform maintains internally. So a little bit about TFAS, the Terraform as a service, and what is this that we are building. So to realize our IAC vision and the tool, the platform that we use to achieve our mission of going from an imperative to a declarative model is Terraform. And we have built an internal private cloud at LinkedIn for Terraform, and that is called Terraform as a service. So Terraform as a service is remote execution as a service. So we provide a platform where users can just focus on authoring the IC files, and they have to run some simple commands to get their infrastructure or application deployed. And in the backend, we take care of doing everything, all the state management for them, maintaining all the state files, which keeps history of and a graph of all the resources that they have, resources and infrastructure that they have deployed. So it basically provides a CI/CD platform for all the Terraform changes that happens at LinkedIn. So here's the TFAS platform architecture that we have. So as you can see, the majority of the components, the backend component that TFAS uses lives in Microsoft Azure. So we use a few of the components from Microsoft Azure, which provide us great availability and reliability. For example, we use Azure Storage Blob to store all the things related to logs and also our state files. And then we have the service bus queue, which we use to transfer the jobs from our server, which actually processes the request from the client, to another worker instance, which actually has the Terraform binary, and it executes all the Terraform operations. So using this platform, the TFAS server and the TFAS worker platform, we have the ability for LinkedIn developers to provision any resources that exist at LinkedIn, the piece of infrastructure that exists at LinkedIn, and also the Azure resources. And next, Wensi will talk about TFAS features and adoption strategy that we are doing at LinkedIn.
Hi folks, I'm Wensi. I joined LinkedIn at the TFAS team since January this year and have been working on the core components of TFAS. Now recently I'm working on building the Terraform provider ecosystem to facilitate migrating infrastructure to use IAC. So following Rahul's introduction, now that we have a MVP for TFAS, the next thing we want to do is to figure out how to migrate all the LinkedIn infrastructure to TFAS. So part of our adoption strategy is make it easy to move to IAC. By easy, we mean less pain points, moving faster, and take the benefits of declarative workflows as much as we can. So all the TFAS features are designed to align with this strategy. So the first thing we want to introduce is TFAS import. It's an import of existing on-prem or cloud resources to TFAS. Now, even though we are well aware of the benefit of IAC, we still find it really difficult to switch to a totally different workflow, especially when CLI UI has been used at LinkedIn for so many years. The learning curve for onboarding to IAC is so steep. Now, how this TFAS import work is that it still allows users to create their infrastructure using CLI or UI of their choice, and then use the import CLI command provided by TFAS which will do two underlying things. One is to import the resources to the TFAS state file, and then second, generate the IAC for the resource and put up a PR including that generated IAC. And once that PR is committed, that means the import is finished, and moving forward, that resource can be fully managed and provisioned by TFAS at any time. Next, Sandbox Workspace. So now that we have imported more infrastructure to IAC, we still find that IAC testing becomes a really low productivity thing, and it causes lots of toil. The reason is that at LinkedIn, we treat infrastructure changes very seriously. So it needs to go through a long iteration cycles when you change your IAC. That means IAC approval, commit, running TFAS plan and applied before we can verify if the infrastructure looks good. Also, many of the TFAS users would face a scenario where they either mix their test infrastructure with their production ones, or they, after the testing, they just jump into another thing and never come back to do the cleanup. So this is not great. And to solve all this, we introduced the sandbox workspace concept that can be assigned to a user, where they can freely run TFAS applied to immediately bring up infrastructure without committing the IAC to master branch, as would a classic workspace requires. So this greatly speed up the testing cycle, and the sandbox workspace itself would expire after X amount date of inactivities, following which TFAS will kick off a automated cleanup jobs to destroy all the infrastructure as well as deleting the sandbox workspace itself. Another thing that we have been working on is DevX, aka developer experience. We integrate TFAS with our review system and utilize the full CI capabilities to trigger TFAS plans automatically whenever we detect a commit that contains IAC changes. We also integrate TFAS with our centralized release tooling service, which consolidates application code change and infrastructure IAC change in one user interface. So user would just need to do their normal click and let the tool figure out how to trigger TFAS actions to deploy the infrastructure and then deploy the application in one shot. We also see in many use cases, user would misread a TFAS plan output where it contains a infrastructure destruction, and the user would just go ahead and destroy it by mistake. So to avoid such cases, we introduce a two-factor approach, which requires the user to pass in an override ID before they can proceed with any destructive operations. Another great toil actually comes from Terraform version upgrades. So software upgrades, as we all know, can be trivia. And so TFAS handles the Terraform version upgrades automatically for the user and let user to focus more on how they want to craft their IC and manage their infrastructure. So there's one question that we have been facing since day one of using IAC, which is, do we really want to replace all the CLI UI workflows with IAC? The answer is controversial. On one hand, many teams at LinkedIn still wants to use IAC. And on the other hand, there's sometimes break glass scenario where there's a fire to put out and CLI must be used to put up a quick fix. So all this leads to the situation where our deployed infrastructure is deviated from the intended IAC. So this is called drift, and this happens so often that we need to figure out a way to happily deal with it. Usually we have two options. One is to enforce current IAC, and the other one is to update IAC to reflect real infrastructure changes, which is the case where we use CLI to put up hot fixes. So TFAS introduced the recommendation engine to resolve drift by first notify users when this drift happens, and second, generate a PR with the IAC changes required to capture the infrastructure changes made outside of TFAS. Yeah, so we are not done yet. We have a list of the other challenges and solutions that we have figured out along the way. So from here, we can see that the migration to IAC is never easy, but we are so happy that we have learned so much from our work to resolve these challenges. So next, Rahul will introduce the TFAS provider ecosystem.
Thanks, Wensi, for providing an overview of the core features that our TFAS platform provides, and also the work that we are doing for easily migrating all the existing users to our IAC platform. So now I'll introduce a crucial component of Terraform TFAS platform, which is the provider ecosystem. So this deals with all the work that we are doing for enabling various providers related to all the services that exist at LinkedIn. So first I'll go through why do we actually need a provider system and why it's very important if you want to enable infrastructure as code at anywhere. So LinkedIn is a very big company and there are a lot of infrastructure teams, on-prem infrastructure teams at LinkedIn. So these infrastructure resources or teams can be classified into categories. So roughly these categories are app resource allocation or deployment, and then there is storage, there is networking, and then finally there's a layer for observability, alerting and monitoring. So since we need to onboard all of these stacks or all of these categories into IAC, then we work closely with these teams to develop a plugin or a Terraform provider so that they can onboard to IAC easily. So just to give you a few examples, for app resource allocation, we have a team at LinkedIn which handles with all the deployment work and all the resource allocation work related to a deployment. Then for storage teams, we have some storage solutions like we have Espresso, we have Venice, etc. For queuing, of course, there's a team which deals with Kafka, and there are various other teams for observability and alerting. So we are targeting all these stacks so that if they come, because they form the core component of what an infrastructure do in any operational environment. So we want to target all these teams and bring them to IC by using a provider, Terraform provider. Also, by our provider ecosystem work, we want to set technical guidance. We want to set standards on creating the provider so that the speed that it takes for users to write a provider is very less. And also it's so that they also get a standard in developing those Terraform providers. So that when after a few years, when we look at the Terraform providers, then we can see that all those providers are written in a consistent and standard way. So the process of building a Terraform provider can be imagined the same way as we build a car in a factory. So I'll just go through all the frameworks, all the tools that we provide, and then compare them with the process of building a car in a factory. At the first stage, when a user or a team wants to onboard to IC or they want to write a Terraform provider, we provide them with a basic set of boilerplate code, a template code that they can just download from Git, and then they can start wiring their logic with that provider. So that template can be considered as an equivalent to a frame of the car that's being developed. So in the next stage, we provide some code generation tool based on the RESTly interfaces that we have. So just as an information, RESTly is the standard library, the standard mechanism, which we use for interacting with our REST services. And also it forms the basis of REST interaction between a client and a server. So we provide code generation tool based on the RESTly schemas. So what it does, it generates all the schema that you need for your Terraform resources and data sources. Now, resources and the schemas for a resource, Terraform resource, are the very crucial part for writing a Terraform provider. So we take off all that work from the user and we do this code generation based on their behalf. Also, in the next stage, we also provide various testing and build tools. We provide Gradle plugins if you want to and integrate them with the product development at LinkedIn so that you can test and build a provider very easily. Finally, in the last section, we have inbuilt module and provider registry, which users can use to upload their Terraform modules, which can be reused anywhere. And then we have a provider registry, which user can use to distribute the Terraform providers and then upload it to all the Terraform machines that we have running. So this is the module registry can be considered as same as the gas station, which is in a way that a gas is needed for your car to run. And the provider registry is the same as dealership, where it gets deployed. So now when you have all this process in check, all these steps in check, then you are ready to start your car, and also your Terraform provider is complete. So now in the next section, Wensi will talk about the impact and also the metrics that we have seen as a result of TFAS users at LinkedIn.
Okay, now it's time to talk about the impact. We will use Fabric builds as an example to demonstrate what we have done using TFAS. So first of all, Fabric is the LinkedIn concept of a stack, a site, or data center as you would imagine. That includes compute, network, queuing, storage, and observability, etc. And so Fabric builds means to spin up all this infrastructure at a time. And previously at LinkedIn, a fabric build times are around 6 to 9 months on average. And this time is okay when we only need to build one fabric every few years. But now as LinkedIn is growing so rapidly, we now need multiple fabrics to be built every year. So the 6 to 9 months timeline is no longer makes sense to us. So using TFAS, we now are able to utilize the work from the provider ecosystem to scale out IAC as much as we can. We generate IAC for migrations using the TFAS import functionalities. And on top of that, we have built 6 functional fabrics so far. 3 of them are production fabrics and 3 of them are testing fabrics. We also built 15 plus ephemeral fabrics. And now it takes no more than 1 to 2 months to build a fabric. Next, some high-level metrics. At TFAS, we are now experiencing over 8,000 executions per month on average, and we are hitting a peak execution for over 40,000. We also have more than 500 users right now, and they are from SRE teams, developer teams, etc. And they have created over 2,000 workspaces so far. In terms of resources, we now have over 7,000 resources that are backing over 200 services within LinkedIn. So today we have introduced why we adopted IAC and created TFAS. We talk a little bit about TFAS features and provide some insights using one of our use cases. Hope this is helpful to you. Thanks for joining.